Okay, we're going to take a good afternoon, folks. We're going to take a look at more on limits. We're going to talk about piecewise and a little bit about trig. The big deal is we're going to get a lot more into trig next class. So we'll start with kind of taking a look at the notes. So sharing the screen. So what we got over here is we have our examples from class. Again, here's the deal with the limit on a piecewise function. So kind of let me zoom in a little bit so we can see a little bit better. We're taking the limit as x approaches 2 of f of x, so the limit of f of x is x approaches 2. As we notice here, this piecewise function has two separate chunks. What it's saying is, with numbers smaller than 2, it's x squared. With numbers greater than or equal to 2, it's 2x. So what we're going to do is we're going to actually look at the two limits from both sides. So we're going to do x approaches 2 from the negative. We're going to look at the limit of the function as x approaches 2 from the positive. So in both cases, we're going to take a look at both of these. So as it approaches it from the left, these numbers less than 2, I'm actually looking at the function x squared. So what I'm going to do is just plug that 2 into x squared. 2 squared is 4. As I approach from the right, I'm going to use the lower function. The 2x is my function. So I'm going to plug in the 2 there. So 2 times 2 is 4. In the world of limits, if the numbers as we approach from the left and the number we approach from the right are the same, the limit exists. So that tells me that this limit is 4. Okay. So usually what is going to happen is the following. You're going to be given a piecewise function. Typically, we're going to be looking at it from that condition that I have here. So this one says it's x squared minus 1 when it's less than 3. This one says it's 2x plus 1 when it's 3 or larger. So again, what I need to do is I need to look at both limits. I need to look as x approaches 3 from the left of f of x. I need to look at the limit as x approaches 3 from the right of f of x. So what I'm going to do there again, when I look at it from the left, I'm dealing with x squared minus 1. So I'm going to go ahead and plug that 3 in. 3 squared minus 1 is 9, minus 1 is 8. This lower one I'm going to look at as 2x plus 1. So I'm going to do 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. These two are not equal. So that tells me that that limit does not exist. So again, it's the same idea, but what we're going to do is instead of just substituting in one, I could potentially substitute in multiple. So again, I'm going to walk through this, the same idea. We're going to look at the limit as x approaches 0 from the left of f of x. We're going to take a look at the limit as x approaches 0 from the right of f of x. So in this case, less than 0 is this guy here, e to the x cosine x. When I plug in 0, I get e to the 0 cosine of 0. E to the 0 is 1. Cosine 0 is 1. 1 times 1 is 1. Then I'm going to look at 2x plus 1. Apologize for the bell. I'm going to go ahead and plug in 0 here. So 2 times 0 is 0. Plus 1 gives me 1. These two numbers are the same. So that tells me that the limit does exist, and the limit there is in fact 1. So that's kind of our limits of piecewise. You just kind of have to do each piece on its own. The thing to be careful about is a problem like this one down here. What I want you to look at is, this is the limit as x approaches 0. The boundaries are 3. So realistically, 0. The only one I care about is that one. So what that means is I only really care about plugging and chugging on this guy, x less than 0 of 3x minus 7. So I'm going to substitute 3 times 0 minus 7, and I'm going to get negative 7. So what that tells me is this limit here is in fact negative 7, because I don't care about this one, because 0 is not greater than 3, so I will never use that one. So that was our limit of piecewise, and the homework really had to do a little bit more with piecewise than anything else. We did get a little bit of a start on trig, and here's how we started on trig. We need to know our trig functions. I'm going to tell you we're still going to try substitution first. So in this case, what I'm going to do is I'm going to go ahead and check tan 0. I gave you all a unit circle today so that you have it as a reference. Tangent of 0 is 0. So that tells me that the limit as x approaches 0 of tangent x is in fact 0 because I substituted. I'm going to go ahead and focus so you can see this one. That's pi. So we're going to plug and chug away. So what we're going to do is we're going to see what happens if we plug in pi times cosine pi. Cosine pi is equal to -1. Pi is pi. Pi times -pi tells me that this guy is going to be -pi. So again, I'm substituting. I'm just telling you, we substitute, we substitute, we substitute, we substitute. If we can, we substitute. So in this case, last one, we're going to go ahead and substitute. The thing I need you to be careful about is that sine squared x is actually the same as sine of x squared. So what I'm going to do is I'm going to take sine of pi over 4. I'm going to square it. The sine over pi over 4 is √2 over 2. √2 over 2 squared gives me 2/4. Gives me 1/2. This guy's 1/2. So again, we talked a little bit on class. It's the substitution using your trig identities or your trig, your unit circle, and to figuring out the answers. I mentioned this in terms of substituting. If substituting doesn't work, if I put 0 in here, it's not going to work because tangent of 0 is 0. If I plug in 0 down below, it's also 0. So what I need to do is I need to somehow factor, rewrite, do something. So what I want you to understand is that this problem right here is actually the same as this. Just kind of split it into its chunks. I can keep rewriting. So what I'm going to say is this. Tangent is the same as sine x over cosine x. And now what I can do is I can kind of rewrite this. And the way I would rewrite this is the limit as x approaches 0. And what I'm going to rewrite it is sine x over x times 1 over cosine x. Basically what I did is I just kind of flip-flopped the 1 and the sine. The reason being, according to our properties, the limit of our product is equal to the product of our limits. So just hang on one sec. Okay, sorry, someone dropped in. I just wanted to make sure I talked to them. So we'll go back to where we were, share screen. Okay, so let me kind of stop and go back to where I said. I said that the limit of a product is equal to the product of the limits. I know it sounds really kind of confusing, but really what I want to tell you is this. I can rewrite this guy as two separate limits. I know according to my identity that this limit right here is 1. So this whole guy over here can be rewritten as 1. And I'm going to go ahead and plug and chug on this guy because I can now actually put in 1 over cosine 0. 1 over cosine 0 is 1. This becomes 1 times 1. The answer is 1. So again, it's going to take practice. I'm going to be honest with you. It's not something that's going to immediately become intuitive, but I will tell you over the course of time, I'm pretty sure you're all going to become pretty adept at this. So the last thing I'm going to talk about is this one right here, sine at 4x over x. I'm going to be honest with you, this cosine thing doesn't really help. There'll be some examples next class where it will be, but I'm going to tell you this is the one we're going to use. But the problem is sine x over x, these variables are the same. So if these variables were the same, that would make life a whole lot easier. We could go ahead and we could just, if we could factor the 4 out of the sine x. We can't factor the 4 out of the sine x. But what we can do is turn this guy in the bottom into a 4x. And the way we do that is we multiply him by 4. If we multiply 4 times x, the denominator is going to be 4x. However, I can't change the value of this function. The way I do that is I do 4 over 4. Because 4 over 4 is the same as 1. If I multiply this guy by 1, it doesn't change it. So 4 over 4 is fine. So what this is going to give me is the following. The limit as x approaches 0 of 4 sine 4x over 4x. So basically multiply the top by 4 out front, and multiply the bottom by 4x. And I'm going to, again, show you how we can break this into its parts. This guy right here, again, is going to simplify to 1. And the limit of a constant is equal to the constant. So that's a 1. So 4 times 1 is 4. So that tells me that this limit here is 4. We're going to do a little bit more practice on our trig stuff next class, but that's just kind of an introduction. The homework had a lot more to do with our piecewise functions. So again, use the reflection if you have questions. Please reach out to me with questions about this, and we'll talk about the homework next class.